Hello guys, welcome back to my YouTube channel. As you all know me, this is Arshini with the USN 1VE23EC011, studying in Sri Venkateshwara College of Engineering, Bengaluru, currently pursuing third semester in the Department of Electronics and Communication Engineering. My today's subject is Computer Organization and Architecture with the subject code BE306C, and today's topic is on bus structure in computers. Firstly, let us see the introduction to bus structure. A bus structure is a communication system that transfers data between components within a computer. It also facilitates the interaction between the CPU, memory, and peripheral devices. Understanding bus structure is essential for comprehending computer performances and designs. Now let us see the definition of a computer bus, or what is a computer bus. A computer bus is a set of physical connections that transmits data and control signals. It serves as a communication pathway for various components in computer system. Buses can classified based on their functionality and designs. Like this is a motherboard bus structure, that is processor, keyboard controller, main memory, video controller, storage disk controllers. And these are the types of buses, and that we'll see in the next slides. And here is the types of buses. There are three primary types of buses, data bus, address bus, and control bus. This is data bus, address bus, and control bus. Each type serves a distinct purpose in communication process. Means each type of buses have a distinct purpose, have its own purposes in the communication process. Understanding these types helps in grasping how data flows within the computer. Understanding these buses can help us to understand how data flows within the computer. Now let us understand three types of buses one by one. And that first one is a data bus. The data bus carries actual data being transferred between components. Its width measured in bits affects the volume of data that can be transmitted. A wider data bus can lead to improved performances in data intensive applications. This data bus is measured in bits, and it also affects the volume of data that can be transmitted. And the next one is address bus. The address bus carries information about where data should be sent or retrieved. This address bus, what is the main purpose of this address bus is it carries the information about the data, where it should be sent or where it should be retrieved. It also determines the maximum memory capacity a system can address. The width of the address bus directly influences the addressable memory space. And these controls will also coordinate with the activities of CPU, memory, and input or output devices. Means it also combines or cooperates with the activities which is done by the CPU, memory, and input or output devices. And now let us see the next subtopic, that is bus architecture. What bus architecture means or defines is that how buses are organized and connected within a system. Common architectures includes single bus, multiple bus, and hierarchical bus systems. The choice of architecture impacts the efficiency of data transfer and system performance. As I told, the common bus architectures are single bus architectures, multiple bus architectures, and hierarchical bus architectures. So let us see one by one what is single, what is multiple, and what is hierarchical bus architectures. And in that, first one is single bus architecture. Single bus architecture is uses it uses one bus to connect all components of the system. That is, it uses only one bus. It uses only one bus to connect all components of the system. And this design is simple and cost effective, but it can create a bottleneck for transfer data. That means it can create some issues for data transfer, and the performance can degrade as more devices share the same bus. As more devices or more components is connected to one bus, the performance will get decreased as per the components connected to the buses. And the next one is multiple bus architecture. Multiple bus architecture employs several buses to connect different components simultaneously. Means here we will have different buses for the different components. But in the single bus architecture, we'll have only one bus which is connected with some one or two or three components to the single bus. But here in multiple bus architecture, we'll have different buses for the different components, and this design reduces computations for bus access and enhances overall performances. However, it increases complexity and cost in system design. And the last one is hierarchical bus architecture. Hierarchical bus architecture organizes buses into levels allowing for efficient data flow. It means it organizes the buses as a level wise, allowing for the efficient data flow. Means here in hierarchical bus architecture, we'll have the levels of buses like level 1, level 2, level 3. We'll have different types of levels. Buses are organized as per the levels, and why it is organized? Because for the efficient data flow or fastest data flow, it separates high speed and low speed devices to optimize performances. Means here the levels buses will have the different speeds, like one bus will have the high speed and one bus will have the low speed. So we here will have it will be having optimized performances. This structure is commonly used in modern computer system for improved scalability. And now let us see the advantages and disadvantages of bus system. Firstly, advantages. Bus system simplifies the design of computer architectures by reducing writing complexity. They enable efficient data transfer between multiple components. Standardized bus system facilitates interoperability among different devices. And the next is disadvantages of bus system. Bus systems can suffer from bandwidth limitations as more devices are added. Contention for bus access can lead to performances bottlenecks. Physical limitations in bus length can restrict system design and scalability. Now let us see what is the summary of this bus structures. The bus structure, it is a fundamental component of computer architecture. Different types of architectures of buses influences system performances and scalability. Continuous advancement in technology will shape future computing systems. And this is the end of our presentation. Hope you liked it. Please like, share and subscribe to my channel.